Hi, I'm Abhishek Lal. I'm a program manager with Windows Azure. And today I want to talk about Windows Azure Service Bus. Service Bus allows you to build applications and connect different roles between web and worker tiers. You can use this for load leveling or for decoupling, where your web tier sends messages into a queue and your worker tier pulls messages off them. We also support some very advanced pub-sub scenarios where publishers can send messages to topics, and then you can have several subscribers pull messages. Today we will go look at some of the new tooling in Visual Studio 2013 which supports development with Azure Service Bus. With Azure, you know that you can build cloud scale applications for the enterprise. One of the key aspects of one of the key services in Azure is the Windows Azure Service Bus. This provides you messaging and relay services, which really helps you unlock enterprise data as well as business logic. With Azure Service Bus, today we will focus on the secure messaging capabilities and how these enable you to build loosely coupled solutions. In addition, we're going to see how you can achieve some rich publish-subscribe scenarios using Azure Service Bus. When we talk about tightly coupled applications, it's the case where a store front end may be talking directly to a shipping service, which directly then talks to maybe the dispatch or the inventory services. This kind of a direct system has a flaw, that when one particular component is unavailable, say the dispatch one, the errors are propagated all the way back because there is no intermediate decoupling to protect from these errors. In a more loosely coupled system, we see that errors are decoupled from the front end and back end by putting a queue in the middle. In this case, all the requests are sent as messages into an order queue. The tracking system can then pull these messages and send them over for delivery. If the tracking system for any reason is unavailable, note how messages from the front end continue to go into the orders queue, and thereby the system continues to work. These orders will not be processed until the tracking system is back online. But at that point, you will be able to retrieve these orders and process them for delivery. All this time, as you saw with loose coupled applications, the front end remained available while the tracking system could be taken offline for upgrades. Consider the scenario where you have several store front end instances. They could be generating peak loads where there are lots of messages and orders being generated which the tracking system cannot keep up with. And at that point, by having an order queue in the middle, you can achieve some load balancing. This is where you have multiple instances of the tracking system pulling from the same order queue. The key distinction here is that you have multiple receivers on the same queue, and they are competing for messages. So the same message is never seen by two instances of the tracking system. But you are able to achieve some load balancing by increasing the number of worker roles you have for your shipping service. With this, let me switch over to Visual Studio and show you some of the developer tools we have to enable development with this scenario. What I have installed here is the Windows Azure Cloud Tools. And here on the left hand side in Server Explorer, you are able to see that I have my Service Bus namespaces listed. If you log in and do not see any namespace available here, head over to the Windows Azure portal at windowsazure.com, and from there you'll be able to easily create a new namespace by selecting which region it is located in. With my namespaces listed here, I can easily enumerate through the queues and the topics which I have created. we provide you with some additional debugging information, so you can go over to a particular queue and view its properties. Note how I'm able to see I have lots of active messages in this queue, when the queue was created, as well as important values like the maximum delivery count and the max size of the queue. So we can see all the different properties that are necessary for this queue. Right from Visual Studio, I have the ability to create new objects, as well as modify all the key properties for that. Once my new queue is available, I can see it has no messages. I can actually send a test message to it, and you will notice that the properties are updated and you're able to see all the latest properties on the queue with the active message count increased to 1. Also note that it shows you when was the last time the queue was accessed. I can go receive a message from here, and that again will bring the active message count back down to 0. These tools really help you debug and get a very, very rich insight into all your active entities with Service Bus. Now to use this, I'm going to create a new project in which I'm going to choose the Windows Azure Cloud Service project. Of the several templates that are available to me, one of them is a worker role with a Service Bus queue. I will add that to my project and hit create. What this gives me is all the code needed for me to go listen on a particular queue for messages and then process these particular messages. Now I have the code loaded here. Let me walk you through some of the different sections here. At the start, we create a particular queue name, say the processing queue. And at that point, we will, in the run method, call a single method of client.onMessage. QClient is initialized in the onStart method, and it uses the particular queue name that you specified earlier. I'm going to change this to my processing queue. When you make an onMessage call, any messages that become available on that endpoint are then sent to your processing function. Note here, I have a simple trace of writing out what message was received. So in the demo, you saw how you can easily create a worker role project and receive on messages from a queue. The one additional concept I want to show you is that of a topic. In this case, the stores are sending messages to a single topic, but there might be multiple subscriptions which are receiving those messages. Think of a case where you have a separate inventory system and a separate tracking system. Here you want the same message to be sent to both, and that is exactly what is happening in this particular scenario. When you create subscription, you can add filters to them which decide which messages go to which subscription. And those messages can be duplicated between subscriptions, or you could have mutually exclusive filters where a single message goes to a single subscription. This kind of rich pub-sub scenarios really enables you to build connected systems by decoupling your front ends as well as your worker tiers and achieving very, very scalable and connected services. With Azure Service Bus, we saw today how it is so easy to build multi-tier applications with web tier and worker tiers both being connected through queues or using publish-subscribe patterns with topics and subscriptions. The Azure tooling within Visual Studio 2013 makes it really easy for you to develop these decoupled applications.